Hello everyone, welcome to the demonstration of chronic disease risk prediction system. I will be explaining about the AWS architecture, or we can say the data flow summary. So considering the first part, which is the input form, I will be going to the first S3 service. So as you can see, we have the verify bucket, and I will go to the index.html, which is the input form for the users. So here it is. As you can see, there are demographic and physical attributes, lifestyle factors, and health and medical data. So this part this is the part in which the user can submit health related data, example age, BMI, blood pressure, etc. And this data is sent as JSON to the API gateway. So let's go to the API gateway. So as you can see, there are two APIs. The verify fetch API means this API. It receives the untouched JSON input from the user, and this API it passes the data directly to the Lambda function for processing. Let's go to the Lambda function. So here are four Lambda functions. As you can see, the first one is verify input data, the second one is S3 to glue trigger, third one is DynamoDB to S3 exporter, and the last one is fetch output. Here the Lambda function acts in two layers. The first one is data ingestion, and the second one is data conversion. In the data ingestion part, the Lambda function converts the incoming JSON into the proper format for DynamoDB. It inserts the data into the DynamoDB table. This acts as a data storage and staging layer for new health entries. Coming to the function 2, which is the data conversion layer. So it is triggered either automatically or manually when new data is available. It reads rows from DynamoDB and convert each row into Parquet format using PyArrow. And after that, it stores the Parquet files in the S3, like the first one service which we got earlier. So after that, let's come to the AWS Glue. So here you can see I have come to the AWS Glue, and here you can see the option of ETL jobs. I will click into that, and here you can see the job is done, its status. Yeah, it is succeeded. And what the glue does actually, it detects new Parquet files in S3. ETL job converts or merges them into a single CSV file. This final CSV is used for batch ML predictions, model retraining, and data analytics or reporting. So this is the AWS architecture. And after that, if I speak about the optional Lambda that is used for automation, so what it does actually, it automatically triggers the glue job when a new file lands in S3, and it ensures end-to-end automation from input to DynamoDB, after that to Parquet, and then to CSV, and then to the ML model. Thank you. Project Chronic Disease Risk Prediction System is an intelligent cloud powered healthcare platform that predicts an individual's risk of developing chronic disease such as diabetes or heart problems before symptoms appear. It leverages AWS services and a random forest regression model to process real time lifestyle and health data and provide personalized preventive recommendations. So why does it matter? Because millions of people worldwide suffer from chronic diseases that could have been prevented if detected earlier. Our system bridges that detection gap using data-driven intelligence. So if we move to the problem definition part, most people realize health risk only when symptoms surface. Traditional healthcare is reactive, not proactive. Our system shifts the paradigm to proactive healthcare, identify risks early through AI-based pattern recognition. So we basically are trying to empower people to understand their own health patterns before the disease takes hold. So the objectives are data collection and processing, collect age, lifestyle, and health metrics through a web-based form. The second is risk level identification, uses machine learning to determine whether a person is at low, moderate, or high risk of disease. The third is personalized recommendations generate preventive suggestions to guide users. The fourth point is scalable platform makes it available anywhere through an AWS hosted website. So we wanted to create not just a prediction model, but a complete preventive healthcare ecosystem powered by automation and scalability. So the system architecture includes 7 steps, which are user submits data through an S3 hosted web form. And the second step is the API gateway sends it to Lambda for validation. The third step includes data is stored in DynamoDB, which is a no SQL, or we can say no schema database. The fourth point is another Lambda converts it to Parquet using PyArrow and sends it to S3. The fifth point is AWS Glue cleans and transforms the data using PySpark, which is nothing the data pre-processing. The pre-processed data is used in SageMaker for model inference. The SageMaker here is used for model training. The seventh point is predictions and recommendations are displayed back on the dashboard. So here, this pipeline is fully automated. Once a user submits data, every step from pre-processing to prediction happens without any human intervention. So if we discuss about the machine learning model, which is here, random forest regression, as we chosen it because it's robust, interpretable, and handles both categorical and continuous data well. Each tree in the forest makes a prediction, and the average gives a reliable risk score. So it reduces overfitting and captures complex relationships ideal for health data where many factors interact. And if we talk about the model performance metrics, we have taken R square, RMSE, and MAP. So the R square for our model is 0.88, the RMSE is 0.09, and the mean absolute percentage error is less than 8%. So these results show that our model predicts risk with high precision, reliable enough for real-world preventive healthcare applications. So the input features for the project is like we have um, taken this input features in the website, like the front end part. So we have taken demographic and physical factors, lifestyle factors, and health and medical data. So if we talk about the risk classification, our model outputs a risk score between 0 and 100, 0 to 33 low risk, 34 to 66 moderate risk, and 67 to 100 high risk. Based on this, the system generates targeted lifestyle recommendations, diet adjustments, stress reductions, or medical consultation. So if we talk about the results and evaluation, the system achieved an R square of 0.88 and RMSE of 0.09. This demonstrates the model can closely approximate actual health outcomes and generalize well on unseen data. So our focus was not just on accuracy but on reliability and interpretability, which is key for healthcare AI systems. So we have concluded that our model has fully automated ETL pipeline using AWS Glue and PyArrow, and it is a serverless computation via Lambda, no manual intervention. It uses real-time prediction, uses SageMaker endpoints, and it is also scalable web hosting via Amazon S3. So every component from data to dashboard is cloud native, scalable, and secure, designed for real-world healthcare scalability. Thank you.
So now let us see how our chronic disease prediction works. This is our index.html and we'll start assessment. We should put our email so that it generates a unique ID every time. Then age, gender, height, weight. And so as per our height and weight, it will generate our BMI. Then region. We should enter some lifestyle factors such as smoking status, alcohol consumption, sleep hours per day, then diet quality, poor, average, or good, then physical activities on a scale of 0 to 10 in hours per week, and stress level 0 to 10 on a scale of 0 to 10. So, 6. Then blood pressure. These are some health and medical data, cholesterol and glucose. So now our data has been submitted successfully and a unique ID has been generated. Let's go to DynamoDB. And so you can see our data here, the inserted data. So it has triggered API gateway and then to Lambda and has been stored in DynamoDB now. Now let's go to our Glue job. So that our data can be processed for SageMaker. Let's go to S3. Let's run our Glue job. Okay, so the job has been started successfully. Now let's go to SageMaker. This is our model. We have used random forest regressor as our model for prediction and recommendations. Now let's sell. So now you can see both the codes have worked. Now let's go to our dashboard to view our health record. We'll put the email. Sorry. So now we can see our health record. So our overall health risk, it is 24.91%. So green color here shows that we have low risk, yellow color shows we have medium risk, and we have red indicator also which indicates we have high risk. So our diabetes risk score is medium due to the cholesterol and glucose. Rest other factors are with low risk. And we have got personalized recommendation also where we should maintain balanced diet with high protein and fiber, exercise daily for 30 minutes, incorporate stress management, and the person should aim for 7 to 8 hours of sleep daily. Now, for example, if a person enters his or her health record many times, so it will generate output for all the records and it will show newest first. So this was the health record which was newly input, which was newly generated. Here you can see red indicator which shows that the person has a high risk of respiratory problems and has got personalized recommendation also. Thank you.